Hello everyone, welcome to the class, and in today's class we are going to be covering some topics from motions in a straight line, right? We were actually doing equations of motion, right? We will complete that and then we will move into the concepts of motion in a plane, alright? And good evening Akshay. And let's begin today's class. And once again, before we begin, my name is Mohana. I'm a physics educator at Unacademy. So if you're taking your class 11 and class 12 physics with Unacademy, I'll be teaching. And this is my Telegram channel. And before any updates are there, it will be shared. And if you check out my Telegram channel, there will be some pool type MCQ questions asked. So you can go and check that out as well. Right, and this is the common Unacademy ISC and ICSE Board Telegram link. You can follow this channel also. So you any updates are there, it will be shared over here as well. Okay, you can follow both the channels. Now, just like how we have the free classes on the Unacademy platform, right? Sorry, on the YouTube channel. Likewise, we also have free classes on the Unacademy platform. Okay, these classes are absolutely free. You can learn from any of your favorite educators, right? And also, the you can engage with these educators via the pool feature. All right, and also since those classes, right, these live classes are also these special classes are also live classes. So if you have any doubts, you can get them cleared instantly as well. Okay, so if you look down in the description box, you will see the link for my upcoming special classes. All right, you can register for this. You can actually join in the same as well. Now, see, the next upcoming special class is because we are starting motion in a plane, right? So we will be covering concepts from vectors as well. So on the next class, that is on 20th, right? We will have a class. This is basically practical applications of vectors. So we'll be learning vectors through examples. Okay. So this class is on 20th June at 4 p.m. So you can register for the same. Anubhav, hi. Right, and also, so you can just click on the link down on class 11. It will take you to all the upcoming classes, so you can register for this class. You can just give enroll. So before the class goes live, you will be notified and you can join the class. All right. So let's meet during this class so we can learn more about vectors through practical applications, right? And then the next class will be on 27. So these classes happen on the platform. So this will be what are the basic mathematics needed for physics. Okay, this is part 2 of the series. So in this series, we will be covering differentiation and calculus. All right. And on the 29th June, again, we will be covering applications of vectors. And again, this will be part 2 of the series. All right. So you can enroll for these classes. And these classes are again absolutely free. And it will be happening on the Unacademy platform. Now, in case if you're interested in the plus subscription, right, there are certain advantages you have. Right, one is you can learn from the comfort of your home, and the next one is whenever you're taking a plus subscription with Unacademy, you're buying 4 courses. One is you are getting math, physics, chemistry, and biology. You're getting all 4 courses over here. All right, and all the educators are actually really good. Right, so you'll be learning from the top educators. Next, every class. This is an interesting feature we have at Unacademy. Right, one is whenever we start a course, every 4th class will always be a doubt clearing session. Right, so every 4th class in your when you start a course will be a doubt clearing session. So whatever doubts you have in the previous, actually all your doubts you can get them cleared in the live class as well. In case when you're revising the concept, if you still have any doubts, or in case if you couldn't attend the class, one of the classes, and if you're watching the class recording, so on the 4th class, right, every 4th class that will be, which is a doubt class, you can get those doubts solved as well. Okay, now in a plus course, we are covering the entire syllabus, right? At the same time, we have a number of practice tests. You can check those out, and also every other week there will be a live test series. Okay, so in the live test series, right after the test is over, right, we will have an analysis session. Okay, so you can actually join the analysis session and get your doubts cleared as well. Now, we are coming up with a new batch and courses. I will tell you these details shortly. Now, in case if you are taking a course with Unacademy, always go for a longer duration. All right, the longer duration course you take, the price you're paying per month, so a price you're paying per class actually reduces. Okay, so if you see here, the price for 3 months is actually just 2,885. But as you go ahead, like if you're taking for price for a year or 2 years, then you are paying only 1,198 per month. Okay, now on top of that, if you are using my educator code, just give me a bit of time. Let's just bear with me for a few seconds. I'm having a technical difficulty, so let me just try to write my code. MT, in case if you're using my code MT, right, IS 10. Okay, then on whatever price you're taking, right, on whatever price that you're getting, you will, whichever duration you're taking, right, whichever duration you're taking, you will get a 10% off on the course. Okay, so if you're paying this amount per month, if you're using my code MTIS10 while taking a plus subscription, you will be only paying 1,078 rupees per month. Okay, now the ongoing course that we have is the course actually started on 8th June, and if you see, the mode of delivery is going to be in English. Okay, and for physics, I'll be taking every 5:15 to 6:15, Thursday and Saturday, Tuesday, Thursday and Saturday, every 5:15 to 6:15, we'll be taking the physics class, all right, for class 11. Okay, and chemistry, again, chemistry classes are held during Tuesday, Thursday and Saturday as well, but 4 to 5. Okay, the next class for math and biology happens between 6:30 to 7:30, biology happens between 4:45 to 7:45 to 8:45. All right. Now, if in case you're in class 11 and taking a plus subscription, you're in an advantage. You can get, if you just take for 1 year class 11 subscription, you're getting class 12 subscription absolutely free. Okay, so you're paying for 1 year, but you're getting the course for 2 years. Now, whenever you're taking a plus subscription in a month, there will be a minimum of 10 classes in physics, a minimum of 10 classes in chemistry, 10 classes in biology and 10 classes in math. Okay, so for these minimum number of classes, that means per month you will have at least 40 classes. Okay, and you're paying only for class 11, but you're getting class 12 subscription as well. All right, on this note, let's begin today's class. So if you see, we would have started with the last class on the kinematics, that is unit 2. We started with kinematic equation, right, for uniformly accelerated motion. Right, so we were seeing what is the equations for uniformly accelerated motion along a straight line path. For that, we did certain assumption. One thing we took was that, let's say an object or an object is going from starting from here and going in towards the positive x direction, right? In this case, let's say this x0 is the position of the object at instant what? At instant t is equal to 0. At time t is equal to 0, this is the position of the object is given by x0. And the velocity associated of the object at that time t is equal to 0 is taken as v0. Okay, that is your initial velocity. Okay, some books takes it as u as well. Okay, so you can take it as v0 or u or v0. Okay, now after some time, what is the time? Okay, after some times the position of the object at an instant t, okay, that is taken as x, and the velocity associated with that object at that instant t, we took it as v. Now keeping this in mind, first we saw what was the velocity after a certain time. After some time, what was the velocity? So to do that, we started with what is acceleration. We started by defining acceleration. Acceleration was change in velocity by time taken. What is the change in velocity? This is the final velocity and this was the initial velocity. So change in velocity will be final velocity minus initial velocity by the time taken. What is the final time and what was the time when it initially started? So t minus 0, right? From here, we got the equation v is equal to v0 plus at. So this is final velocity is equal to initial velocity plus acceleration into time. So this gives the relationship between velocity and time. So anywhere if you're seeing a question which has a relationship between velocity and time, you can use this formula, right? Now, next condition that we have taken, I am crossing this, I am not doing these equations because we have done these two in the previous class and we have done the calculus method also for the same. Okay, next one is when your distance, now first we saw what was the velocity after a certain time. What was the velocity after a certain time? Now, what is the distance covered after a certain time? So if you want the distance equation, what will you do? You start with average velocity, right? So velocity is what given as displacement by time. From there we began the equation and we got two equations. Now this first equation over here gives you the relationship of position time relationship, and this equation over here gives you the distance time. This gives you the distance time relation, x basically being the position. This gives you the position time relation. Now x minus x naught, if you take this x naught to the other side, x minus x naught, x minus x naught. So this basically gives you the displacement, right? It gives you the distance. So that is, from this equation you can get distance time relation. Alright, till this we have done. We have also done by calculus method. So I hope you do not have any doubts still here. Right, so can I go ahead from here? And alright, on that note, let's do a numerical. So you can guys start giving me the answers in the chat box if you know, right? So the question over here asked is, a jet plane starts from rest at with an acceleration of 3 meters per second square and makes a run for 35 seconds before taking off. Okay, what is the minimum length of the runway and what is the velocity of the jet at takeoff? Okay, so this is the question asked over here, right? This is the question asked. So how would you solve this question? First, let's talk about the minimum length of the runway. What equation will you use for minimum length of the runway? What would be the equation that you're using for minimum length of the runway, right? Just try doing that. I would be back in a second, right? You can give me the equation in the chat box. I'm sorry about this. Just a minute. Okay. Okay. So here, what is the first thing we need to find? We want to find what is the minimum length. Okay. Minimum length of the runway. When you're talking about minimum length of the runway, we want to find displacement. Okay. What is the equation that connects displacement? So here you can say a plane starts from rest. Acceleration is given. Okay. And it makes a run for 35 seconds. So 35 seconds T is given, right? Before taking off, it is starting on the runway from position, let's say, right? Let's say from position X over here, right? To its takeoff position, right? This distance it covers, we want this distance. Okay, so for this distance, right, and it makes a distance what? It makes a run for 35 seconds. So to cover this distance, T is given as 35 seconds. Okay, and also all of the questions here are taken from your reference books, and this question is taken from the New Simplified Physics, all right, by S.L. Arora. So here, if you see, this is the distance and this is the time it takes. Now you need the relationship between distance time, right? So here you can use distance time relation, right? You know the time and you want to find the distance. So distance time relation, what is the relation over here for distance and time? We know S is equal to, okay, S is equal to UT, right? Right. S is equal to UT. Actually here we would have taken as V0 T, right? This V0 T, some books takes it as UT. So we can take it as V0 as well. Right, here we know S is equal to V0 T plus half AT square. Right? We want to find the displacement. Right? Before the plane could take off, what was the distance it covered? That is what we want to find. Right? So the plane goes and before it could take off, what was this distance on this runway? This is the S we want to find. We know time is 35 seconds. Right? So here what do we know? S is equal to, what was the initial velocity at position P? At position at T is equal to 0. What was the velocity in that case? Right? At that point velocity would have been at T is equal to 0. It is just starting off, right? But time, it starts with T is equal to 0. Right, and then it goes on up to T equals to 35. Starting velocity is also 0. So this quantity will become 0. V0 T will become 0. Right, now half acceleration is actually given in the question itself. Acceleration is actually given, A is given in the question to be 3 meter per second, right? So here you have 1 by 2 half, right? A, acceleration is given into time. What was the final time? At takeoff, t was equal to 35 seconds. At takeoff, t was equal to 35 seconds. So at this time, t will be what? 35 square. T square is 35 square. Okay. So from here, if you solve for this, you will get somewhere around, so this is half into 3 into, right, 35 square, right? So you can use a very short trick when you're squaring numbers like this, right? You can take 35 when you have to square a number ending with 5, right? There's a very small trick, okay? So you can take 3, add 1 to it, you'll get 4, right? Now, you'll get 4, right? Now multiply 3 times 4, this is 12, right? Similarly, you have 5. So 5 times 5 is 25. So you get answers for 3 square. This is a simple Vedic math trick you can see, right? So you can get the answers in 2 parts. You don't have to keep using your traditional ways, right? So here you can use the second part of the answer. You can do 5 times 5, you get 25. First part is you have 3, multiply with 4. 3 4s are 12. So the answer to this question will be 1225. So into 1225, if you multiply this, right, this will basically give you 1225. So if you solve for this, what is the value you'll be getting? Right, you can just give me the answer in the chat box if you know the answer. If you're solving the answer, you can give the answer for this in the chat box. So S will be what? In this case, S will be equal to 1837.5 meters. That will be your value. Okay. Now, all right. Now from here, let's see. First part is done. We found what is the minimum length of the runway. Next is what is the velocity of the jet at takeoff. At takeoff, what is V? Okay. So this you can get. We know acceleration. We know time. Using that, how can we find velocity? So here we can make use of the equation. V is equal to U plus AT, because we know A and we know T, right? So here, what is V is equal to? What will be the initial velocity? Initial velocity at takeoff, right? If you're talking about initial velocity, right, we do not know. What the initial velocity is basically 0. U is 0, right? Initially it was at rest. From rest it's moving. So initial velocity is 0, right? 0 plus what is A? Acceleration. We know acceleration is given in the question itself, right? This is 3 into time. Time is 35 seconds. So 3 times 35. 3 times 35. Again, very simple, right? This would be around 9, right? 3 3s are 9, and then you will have 15. So this will be around 105 meter per second. Meter per second is the unit. Okay, because why? Acceleration. Here the unit will be because of acceleration. Acceleration is meter per second square. Time unit is second. So this cancels. So all you will have is meter per second square. Okay, so that will be the answer over here. So if you have any questions or any doubt regarding this, you can ask me in the chat box, right? Otherwise, let's continue. Okay, till this, whatever we have done, for that I have given for whatever equations we have derived in the last class, I have given a problem related to it. Now let's continue with what we were doing. Okay, we were actually looking for equations for uniformly accelerated motion along a straight line path, right? Now last class we saw the distance velocity time relationship. We also saw position time relationship and distance time relationship, distance and time relationship, and we also saw a quick overview of all three, right? Now this class we will cover what is the velocity at a certain position. Okay, now when you're talking about velocity at a certain position, similarly, right, just the previous case, right, the object is going along the positive x direction, right, it's going in one direction, and after a particular time, the time that we started considering, it was at a position x0. At that time we considered that time is equal to t is equal to 0. At that point it had a particular velocity. After some time, right, its position was x, right, it traveled some distance. Now its position is x, so let's say it's moved by 5 meters. Now its position is equal to 5 meters, right? It has moved some 5 meters. Time, let's say the time taken is around 5 seconds. So it's around 5 seconds has been there, and the velocity for that also changes, right? Now in this case, let's see when velocity at what will be the velocity at a certain place. Now we'll make use of the previous equation that we already know, that we know the initial velocity is equal to final velocity plus acceleration into time, right? From here we know v minus v naught is equal to what? Acceleration into time, right? V minus v naught, what is this quantity? What does this quantity gives us? V minus v naught is nothing but your average acceleration. Sorry, average velocity. Initial velocity minus final velocity will give you your average velocity. Okay. From here we can see that average velocity is what? Is equal to the acceleration into time, right? Or average velocity, right? Or we can actually take average velocity into time is basically displacement. We can actually take this as well, right? This is this gives you the average velocity. Now what is this average velocity? We know average velocity is what? Average velocity is nothing but the total displacement, right? The total displacement by time. We know total displacement by time. From here displacement will be what? Average velocity into time. Okay, that's what is given in this equation over here. Alright, that's what is given in this equation. Average velocity into time is equal to displacement. Okay, what is average velocity in this case? Average velocity, we just saw average velocity is nothing but v minus, right, v naught. Okay, v minus v naught, right? Average velocity, average velocity, when you're talking about average velocity, I'm really sorry about this, right? This is your velocity. This actually gives you the change in velocity, right? But when you're talking about average velocity, right? When you're basically talking about average velocity, velocity will be initial velocity. What is your final velocity plus what is your initial velocity by 2? That will give you the average velocity. What is the final velocity plus the initial velocity by 2 will give you the average velocity, okay, into time. Okay, this is equal to displacement. What is the displacement over here, right? The displacement is given by this position, right? This was the initial position, this is the final position. So displacement will be what? X minus x naught. Alright, that's your displacement over here. So the displacement over here is x minus x naught. So very simple, average velocity is distance by time, velocity is distance by time. From there, displacement by time, displacement is equal to velocity into time, right? So what is average? In this case, we are taking average velocity. Average velocity will be initial velocity plus final velocity by 2, right? That is your average velocity. Into time is equal to displacement, right? Displacement, we got it from the graph there, right? Now, here we can say, from here we can actually see that v plus v naught is equal to, we can take this as 2 into x minus x naught, and let's say I'm bringing the t down here. Okay, now you have an equation which has v plus v naught, right, which is equal to 2 by t x minus x naught, and we have another equation here which is v minus v naught, which is equal to a into t, right? Now you can actually equate these two equations, v minus v naught, okay, into v plus in this case we are saying v minus v naught, right, and we have v plus v naught. So what we will do is, this is one equation, right, this is one equation and this is another equation, right? We'll multiply 1 and 2. So we'll have v minus v naught into v plus v naught, okay? This will be equal to what? 2 by t x minus x naught, okay? What is v minus v naught? Is equal to a into t, right? So this will be into a into t. Okay, so let's solve for this. This is x, v minus v naught and v plus v naught. What equation is this? This is in the form, this equation is in the form, okay, x minus y and x plus y. X minus y and x plus y, the equation is x square minus y square. Alright, so we can write this v minus v naught in the same form. So if you write v minus v naught, what would we get over here? In this case, we will be getting, this will be v square minus v naught square will be equal to 2 by t, right, will be equal to 2 by t, and in this case you will get t and t will basically cancel here, right? Sorry, t and t will cancel here. So you t and t, in this case time will basically get cancelled. You will have 2 into a x minus x naught. Okay, now from here we can say v square, final velocity, right, v square is equal to v naught square, okay, plus 2a x minus x naught. right? Now this equation, right, relates velocity to position. This is relating velocity to position. So this gives you the velocity position relation, right? X basically talks about the position, right? Velocity to position. Now similarly over here, let's say we are x minus x naught. X minus x naught is what? It just talks about the distance traveled in time t, right? In distance traveled in time t. What is the distance traveled in time t, right? That is nothing but what is the distance traveled in time t? That will give you the displacement, right? So distance traveled in time t means this is basically giving you the displacement. Okay, just give me 1 second, guys. I'm having a bit of technical difficulty. Right. Okay, so here we can write v square minus v naught square, v square is equal to v naught square plus 2a. Instead of this x minus x naught, instead of x minus x naught, this just talks about the displacement, right? The distance traveled by the object. So that is basically gives you the displacement S. So now this equation gives you the relationship between velocity. This gives you the relationship between velocity and displacement. Alright, so here we have derived two equations, that is velocity at a certain position. We have actually derived two equations. One equation connects velocity with position, so it's called as the velocity position relation. Another connects velocity with displacement, so it's called as the velocity distance, displacement to distance, velocity distance relation. Alright, so if you have any doubt with this, you can ask me now. Alright, now we did this, right? Let's try doing the same in, using the, let's try doing the same equation, this time using the calculus method, right? Okay, so 1 second, just a minute. Okay, guys. Alright, just a second. Okay, now this gives you, this is the third equation of motion, but for the calculus method we are going to make use of the formula acceleration, alright. We are going to take the derivative, the first derivative of acceleration, which basically talks about your velocity, right? Now I'm sorry about this. Tazeen, hi. I'm really sorry about this. Just give me 1 second. I'm good, Tazeen. How are you? And here we can actually write, right? Now we can define acceleration as what? This is by calculus method, right? Rate of change of velocity with time, right? That gives you your acceleration. Oh, I'm sorry about this. Let me just see. Okay. Alright, I'm sorry about the delay, guys. Acceleration is given by what? Rate of change of velocity with time. Okay. Now, how can we write rate of change of velocity with time? What we are going to do is, I'm just going to divide, right, and multiply this term with ds. Okay. So, here we have dv by ds, right? This stays as it is. But what is rate of change of distance with time? Rate of change of distance with time is, alright, rate of change of distance with time is basically given by velocity, right? So here, right, we have the equation acceleration is equal to dv by ds into velocity, right? So here a into ds, we'll take this ds to the other time, okay, into dv into v into dv. Alright, now when, let's make a small assumption, okay, when time t is equal to 0, okay, then velocity, let's take the velocity to be, in this case instead of v0 we'll use u, okay, and let's say the distance traveled, okay, the distance traveled, what was the distance traveled, okay, at time t is equal to 0, velocity is u and distance traveled is basically you're going to be 0. Time t is equal to 0, velocity, that is the object has a particular velocity and the distance traveled is actually 0, right? Now when time is equal to, when it is at a particular time, right, after a particular time, right, initially time was 0, now after it could be few minutes or few seconds or few hours, so after some time, okay, from here we can see what is the velocity, right? So let's say the velocity is equal to v, right, and let's say the distance traveled, okay, distance traveled is equal to s. Okay, now if you integrate the above equation, okay, we're going to integrate this side, it's a function of distance, right? So we're going to integrate acceleration into ds, but since it is a function of distance, so what we're going to do here, we're going to integrate from with respect when the distance, when you started traveling, that is when distance was 0 to distance of was s, right, to here it is a function of velocity, right? So this side it will be from when the initial velocity, when the time was 0, what was the velocity? U. When time was t, what was the velocity? V. From integration u to v dv. Okay, so here acceleration you can take commonly outside, this side velocity also, right, yeah, this side acceleration you can take commonly outside because that will be constant, right, because here it is a function of displacement, right? So this is equal to integration of u to v dv, right? What is from here, what is integration of ds? Okay, integration of ds is basically s, right, from 0 to s. Similarly, integration of v will be what? Integration of v dv. Integration, okay, if your integration x dx is nothing but x to the power of, right, whatever the value is, x to the power of n dx means x to the power of n plus 1 by n plus 1. This will be the integration value, right? So here x to the power of v to the power of 1, right? So it will be v to the power of 1 plus 1 will be 2 by 1 plus 1 will be 2. Okay, within the limits, in this case u to v. Okay, so I'm just going to do the rest of the calculation on the side. Alright, so from here if you see, you get a is equal to, in this case this will be s minus 0, here it will be v square by 2, this will be v square by 2 minus, next you have to substitute, instead of v you have to use this u, right, this will be the initial velocity u square by 2. Alright, here then you will have a into s is basically equal to, right, let's bring this 2 to the other side. If you bring the 2 to the other side, you will have v square minus u square. So you basically get the third equation of motion, which is v square minus u square is equal to 2as. This is by calculation method. Okay. Alright. From here, let's move on towards the next one. Alright. Yes, Tazeen, if you have any questions, you can ask me in the chat box. Relevant to the topic we are teaching. Right? You want me to repeat which one do you want me to repeat? So one thing you can do is you can actually go back, right? You can just go back a few seconds and rewatch it in case if you have any doubts. Go back. You can actually use the keyboard to go back, right? There is a way to, you can just go back to the lecture and you can actually see what is being taught as well, right? Alright, so we have done this. So once again, quick overview by the calculus method, right? So here for calculus, we are considering acceleration as velocity by time. All we are doing here is we are just multiplying and dividing by ds, right? So the displacement you're taking, when you're taking rate of change of velocity with time, you are multiplying and dividing by a change in distance. Okay, change in displacement. All right. Now dv by dt, right? dv by ds we are keeping it, but rate of change of position or distance with time is what? Velocity. You're taking the ds this side, a ds is equal to v dv. Okay. Now at time t, velocity is u, distance traveled is 0. At time t, right, time 0. At time t, velocity is v. In this case, there is some velocity that's occurred, right? That will be the final velocity that you're taking in v. Distance traveled will be s. Now you're going to integrate on both sides. This side it's a function of distance, so you'll integrate from 0 to s. This side it's a function of velocity, right? dv, you're saying talking in terms of velocity. So you will integrate it from what is the initial velocity it had, time was when time was 0, to what was the final velocity it had, time was t. Okay, a over here you can take it outside because anyway this integration is dependent on only the distance. So a becomes a constant, you can take that outside. So integration of ds will be s, right, from 0 to s. From here you get from here you bring this s if you're substituting instead of this value, you'll get s minus a. Similarly on the other side over here, okay, similarly on the my name is Mohana Thara C, and you can see my name and the details in the description as well. Now in the second part of the equation, right here, this is integration of v dv. v dv is what? In this case it is like v to the power of 1 is there. So if you integrate it, v to the power of 1 plus 1, that is 2 by 1 plus 1, 2, right? So it will become v square by 2 within the limits u to v. Right, now you substitute for the same, instead of this v, you will substitute v first, minus, instead of the v, you will substitute u, right? Now in this equation, I am just taking the 2 to the other side. So you will have 2as, this quantity is anyway 0, v square minus u square. From here you can get v square minus u square is equal to 2as here. This is your third equation of motion. Alright, and I hope this is clear as well. Okay, now this we have done both by integration and as well as by the normal method we started with. Now let's see the fourth equation that we want to do is basically what is the distance covered in time. Okay, now let's say at this position over here, let's say that this position over here, time is equal to 0. Okay, after some time, right, let's say t is equal to n minus 1 to after some times, let's say t is equal to n. Okay, now if you want to find out what is the distance covered in nth second, right, this you can obtain by subtracting, okay, what was the distance traveled in the first n minus 1 second and what is the distance traveled in the first nth second. If you want the nth second, then you can actually find out by subtracting this time, what was the time, right, in n minus 1 second to what was the distance covered in the n minus 1 second to what was the distance covered in the nth second. If you're subtracting these two, you will get what is the distance covered in the nth second. Okay, let's say the distance covered in this part, let's say the distance covered in this part, right, let's say this is basically, in this case, distance covered from t is equal to 0 to 2 is equal to n minus 1. So the distance covered, let's say this is equal to n minus 1. At n minus 1 second, what was the distance traveled? Okay, and let's say this gives you the distance traveled. This gives you the distance traveled. In this case, it will be from t is equal to 0 to this time, means what is the distance traveled from the initial, when time t is equal to 0, from the object started moving to when it started reaching this time t is equal to n, right? At this time, what was the distance traveled, right? This is basically given by Sn. Okay, this is given by the distance. This is the distance traveled during the nth second when t is equal to n, right? This could be somewhere around, let's say t is equal to n, right? Then t is equal to somewhere around 2 minutes, right? So this could be what was the let's say distance traveled at 30 seconds. Okay, now t is equal to 30 seconds. Now this will be what is the distance traveled by the object for 30 seconds. Now n minus 1 means 30 minus 1. What was the distance? This will give you time at 29th second, right? So what is the distance traveled at 29th second will be given by this one. Now if you want to find out what is the distance traveled by the nth second, then what you can do, you can find this distance and this distance and subtract from this distance, you can subtract this distance, right? Then what you will be getting is basically, you will basically get this distance. Okay, so this would basically be your distance traveled in the nth second. So this will be the distance traveled in the nth second, right? So if you find this distance and subtract this distance from here, you will be getting this distance. This is the logic used. Okay, now what is the distance traveled? Let's say for the distance traveled for the first distance traveled for the first t seconds. Okay, distance traveled for the first t seconds. So this distance traveled will be given by what equation? It will be velocity, initial velocity times into t plus 1 by half a t square, right? So this will be given by this equation, right? Now the next part is what will be the distance traveled? Let's see what will be the distance traveled in the nth second, the first nth second. Okay, so let's say the distance traveled in the first t seconds, right? And then distance traveled in the first n minus 1 second. What is the distance traveled in the next n minus 1 second? N minus 1 second means here distance traveled at t seconds is v naught into t half a t square, right? Distance traveled in n minus 1 second will be what? V naught. In space of t we write n minus 1, right? So this will be half a into n minus 1 the whole square. Okay, if you have any doubts you can ask me in the chat box, right? Now what will be the distance traveled? Now what will be the distance traveled in the nth second? Okay, just a moment. Okay, now the distance traveled in the nth second. Okay, distance traveled in t seconds is this one. So distance traveled in nth second means it will be v naught into n plus half a n square. Okay, now from here if you want to find out what is the distance traveled in the nth second, right, that will be distance traveled in this minus distance traveled by this, right? But this distance minus this distance will give you what is the distance traveled in the nth second, right? So let's do that. So we have distance traveled in the nth second is actually given by distance traveled, this distance, that is Sn, distance traveled in the n seconds when t is equal to n seconds, minus distance traveled when t is equal to n minus 1 second, right? When that is a distance traveled in n1 minus 1 second. And we have the equation for the same, right? This is given by v naught n plus half a n square minus this equation is given by v naught, right? Let's use this. Okay, v naught n minus 1 plus, right, plus half a into n minus 1 the whole square, right? So this equation stays as it is. Let's reduce the other one. So here we have, let's take this v naught inside, v naught into n minus v naught, right, plus half into a into what is n minus 1, right? N minus 1 the whole square. This is similar to a plus a minus b the whole square, right? This is n square minus 2n, right, plus 1, right? It will be this value. Okay, now from here if you write, this will be v naught n plus half a n square. Okay, now let's write this one also. This will be v naught n minus v naught, okay, plus let's take this half into a n square, let's take this term inside, minus half into a into 2n, right? When you do that, 2 basically gets cancelled here, right? All you will have is a and n. When you take this term and multiply with this, 2 gets cancelled, you will have only a into n. So minus a into n. Okay, then if you take this again inside, you will have plus 1 by 2 into a. So that's a by 2. Right? Now let's take the minus sign inside. So you have this is s is equal to n second, right? V naught n plus half a n square, right? Plus a half a n square is basically equal to what? Is basically equal to minus v naught. Just a second, guys. I'm really sorry, guys. Just give me one moment. Okay, minus v naught into n, right? Plus v naught, right? Again, minus 1 by 2 a n square plus a n minus a by 2, right? Now, here, plus 1 by 2 a n square minus 1 by 2 a n square will get cancelled. V naught, these two terms will get cancelled, right? See, this term and this term gets cancelled. V naught n and minus v naught n gets cancelled. So what will we have? All we will have over here, that is s is equal to n second when you're taking, you will have v naught, right? Then you will have plus a n minus a by 2. These are the two terms that you will have, right? Right. So let's try to, here you can actually take a outside, so you'll have n minus 1 by 2, right? Now let's try to take the 2 also outside. So if you want to take the 2 outside over here, then you are actually multiplying this term, right? You can actually multiply this term with 2n by n, 2n by 2 minus 1 by 2, right? Then what can we do? We can take the 2 commonly outside. So we'll have a by 2 v naught plus, okay, a by 2, okay, into we have 2n minus 1. So this is the equation for distance traveled in the nth second. Okay, once again, if you have any doubts, you can ask me in the chat box. Alright. Okay. Now, this till now we saw what was the kinematic equation for uniformly accelerated motion. Right. Now, in case, right, but what about in case of what will be the equations of motion, like when an object is under gravity? Because whenever the object is, let's say you're throwing an object up, so it will come down, right? So the body near the surface of the earth is always accelerated downwards because of the influence of gravity. Okay, now in the case of absence of air resistance, now the acceleration near the surface of the earth will always be the same, right? Now, now whenever an object that is falling towards the earth because of gravity, then we say from a particular height, then we say the object is under free fall, right? The acceleration the object has because of gravity, right? We call that as acceleration due to gravity, and that particular acceleration is given the value g. All right. Now, what will happen to the equation of motion for an object which is under free fall? Okay. Now, you will have the same equations. Okay. Right. So, you will have the same equations, but in this case, instead of acceleration, the term you would be using here would be, instead of acceleration, you will use acceleration due to gravity, right? So, you will have, I'm really sorry about this, guys. Just give me 1 second. Right. So, when an object is under free fall, then you give acceleration as right. So, you actually write the acceleration over here, right? So, what happens to the 3 equations of motion? The first one, we give it as v is equal to u plus at, right? Here, the object is under, the acceleration is because of gravity. So, when acceleration due to gravity comes in, instead of a, you use g, right? So, first equation, it becomes v is equal to u plus gt square, right? Instead of at, you becomes gt. Second equation, what happens to it? It will become s is equal to displacement and time, right? This will be ut plus half gt square, okay? And the third equation of motion, if you look at it, this will become v square will be equal to u square plus 2gs, or in this case if you want to write it as, or you can write it as v square minus u square will be equal to 2gs, right? Here near the surface of the earth, the value of acceleration due to gravity, this g value is around 9.8 meter per second, right? This is for acceleration because due to gravity. Okay, now whenever an object is under gravity, okay, as it's falling down from a height, as an object is falling down, right, its velocity increases. From a particular height, the object is falling down, its velocity increases. So g value will always be taken as positive. But in case if you're throwing a ball up, when an object is going up, what happens? It covers a particular distance, but because of gravity, its velocity will keep decreasing. It reaches a particular height, it comes back, right? So in this case, when you're throwing it up, velocity is decreasing, right? So in velocity is decreasing means g in this case is taken as negative value. Okay, for down, when an object is under free fall, then gravity is in this case is taken positive. When acceleration due to gravity is positive, but when the object is actually thrown upwards, the acceleration is basically taken as negative. All right. Okay. Okay. With this note, since we have only very few minutes, let's just quickly see the introduction to motion in a plane. Till now, right, when we did motion in a straight line, as we saw in the beginning class, motion in a straight line was because of what? It was basically we were dealing with objects that was going in one dimension, right? Motion of an object in one dimension, that's what we are going. So in a one dimension space, when we go talking about, when you want to say an object is moving forward, or when you're saying an object is moving backwards, you can use positive or negative values, right, to represent the different directions it's going in, because it's in one direction. So either you can say it's going in the positive direction, or you can say it's going in the negative direction, right? So any direction you want to give, right, in case of position, displacement, velocity, you could just give it by positive or negative sign. But when you're talking about motion in a plane, when you move into 2 dimensions or 3 dimensions, motion in 2 dimension gives motion in a plane means we are considering 2-dimensional motions, right? So when 2 dimension comes into play, right, what happens here? Okay, here we can see that you cannot just deal with just say positive or negative directions, right? Here a large number of directions is taken into consideration. Okay, if you want to deal with that effectively, right, we can't just keep using positive and negative directions. So here we introduce a quantity called as vector. Okay, so a vector quantity is nothing but a quantity which has both magnitude and direction. All right, so motion in a plane. So before we begin, right, we have to understand the concept of what is a scalar and what is a vector. Okay, so what do you think is a scalar? What is a scalar quantity? What is a vector quantity? What would be a scalar quantity? Now, any physical quantity you're taking, okay, which have only magnitude. For example, you're talking what is the mass of a particular object. Okay, let's say the mass of my phone is around let's say around 50 grams. Okay, then we are talking about only a magnitude. We are just talking about a numerical magnitude quantity, right? Then it is a scalar quantity. Some of the example of the scalar quantity would be mass, right, volume, density, time, temperature. All of these are scalar quantities, okay, including your electric current. Okay, now if an object, right, it has both magnitude and direction, all right, then we say that is a vector quantity. All right, so when you're talking about vector quantity, direction aspect comes into place. All right, so in case if you're talking about distance, right, what is the distance covered from point A to point B, right, that is a scalar quantity. But when you're talking about displacement, right? You're talking about what was the initial position, what was the final position. At that time, direction component along with the magnitude, direction component also comes into picture. Okay, here you're actually saying in which direction. Let's say what is the velocity of a particular car. Then you say, okay, this, let's say the car is going around 5 meters per second, but in which direction? We also specify, is it going north, is it going northeast, south, right? Even the direction component comes into picture. Then it is basically a vector quantity. So displacement, velocity, force, acceleration, all of these are momentum, all of these are vector quantities. Okay. Now with this note, because we are going towards the end of the class, I'm ending here. In the next note, we will start with the motion of a plane. We will start discussing more about scalar and vectors. Okay. And what is the representation of a vector? Representation of a vector is very simple. Whenever you want to represent a particular vector, let's say a car is going in this particular direction, right? Then you can actually represent it, right, by a straight line, right? Let's say it's going in this direction. Now, what is the length? Okay, a length of this particular vector gives you what is the magnitude of the vector, and the arrowhead points towards the direction. Let's say there is another car going in this direction. Okay, then length of the vector, see, compared to the previous one, this length is actually shorter, right? So this magnitude is length, and you can say this is going in this direction and this one is going in the opposite direction. So this is how you represent a vector. Alright, so with this note, we are coming towards the end of the class, and there is an ongoing batch. So the batch started only on 8th June. So in case if you have missed the first few classes, you would be given the class recordings and you can watch the class. And as I said at the beginning of the class, every fourth class in a plus subscription, if you're taking a plus subscription, every fourth session is basically a doubt clearing session. Okay, so in the doubt clearing session, if you have any doubts, right, if any doubts you have in the class recordings you have watched so far, you can ask the same. Okay, now whenever you're taking a plus subscription with Unacademy, you're getting all 4 subjects. You're getting math, physics, chemistry and biology. So I'll be taking physics, and we will be meeting every Tuesday, Thursday, Saturday between 5:15 to 6:15 p.m. Okay, and in a month there will be a minimum of 10 classes for physics, 10 classes for math, 10 classes for chemistry and 10 classes for biology. So totally in a month you will have 40 classes. So this is the minimum number of classes you will get per month. Okay, other than this, every alternative week there will be other than the practice test available on the website, there will be also live practice test series that happens, and after the live test series there will be analysis session also. Now whenever you're taking the plus course, right, whatever payment you're paying for the plus course, it's for all 4 subjects. Alright, and if you're taking a class 11 subscription, you guys are in a great advantage. Class 12 subscription is absolutely free. So you're paying for 1 month, but 1 year, but you're getting the course for 2 years. Okay, so 1 year you're paying for class 11, class 12 course, that 1 year course is absolutely free. Alright, then so you're only paying for 1 year. Alright, and you can use my code MTIS10 to avail a 10% discount. And also this offer, right? So you can avail a 10% discount using my code. So whatever price you're paying, use my code to get a 10% off. And here for class 12 also, this is an ongoing batch again. So even in class 11, the focus of this batch is going to be a midterm syllabus coverage. So we will be concentrating on your term 1 syllabus. Okay, the first 5 chapters will be covered in this batch. All right, and again we are introducing the community feature, so you don't have to miss any updates from your favorite educators. So in the description box there is my community link will be there. You can go there, you can share your feedback about the classes via pool features, right? And also if you go to the community, I would have asked few questions from unit 1, right? From your physical world and measurements, right? There will be few pool MCQ types questions. You can try attempting the same as well. Okay, and in case if you're watching if you spot any inappropriate content in any of the videos, and if you're reporting the same, you can claim a prize. All right, that's this box bounty. And if you like the video, please share it among your friends as well. Okay, and like the video and subscribe to the channel, and also click on the bell icon so you'll be notified about the upcoming classes. If you have any questions, I'm happy to stay back and help. Otherwise, we'll be ending the session today. And again, tomorrow by around 12 o'clock, there is another session happening. For class 11, tomorrow morning around 12 p.m. we would be having a class, And in that class, we would be discussing about accuracy and what is accuracy, what is errors, precisions, and also we'll be learning about error analysis. All right, guys, with that note, I'll be ending the class today. Thank you for taking the class.